Hey everyone, welcome back to Module 4 of the CompTIA A course. Today's module title isn't nearly as long as the title of Module 3, but it's still a mouthful. The title is Installing, Configuring, and Troubleshooting Storage Devices. And as you can see, this module is mostly about storage devices. Isn't the only thing, but it's mostly about storage devices. And with that being said, I think let's have a look at some of the main topics we're going to be discussing in this specific module, which are installing memory, install and configure mesh storage devices, install and configure removable storage, configuring RAID, and lastly, troubleshooting storage devices. So yeah, guys, now that we've got the topic out of the way, you know what to do. Give the video a like. It does help my channel a lot if you guys give it a like. And if you haven't done so already, maybe consider subscribing down below, preferably with the notification bell. Otherwise, you're not going to know when the next video comes out for this specific module, being module 5. I think this course has got about 18 modules, if I'm not mistaken. I mean, that's a lot of content. So there's a very good chance you might miss out on one of the modules if you don't subscribe to the channel. So guys, I think since we've got that out of the way, let's go and jump in. Alright everyone, let's look at our first main topic for today, being system memory. Now before we just jump into things, I just want to point out that these 4 bullet points you guys see here, some of them are actually in fact the same thing. This is just how the course puts it out. So system memory, RAM, volatile, they are actually all the same thing. This is just how the course explains it. So don't shoot the messenger. So let's take a look at the first one there. The description says the main storage area for programs and data when the computer is running. RAM, which stands for random access memory, that's an abbreviation you guys need to know for the exam. This is principal storage space for computer data and programs instructions. Volatile, a type of memory where data cannot be stored without power being supplied. Now, with regards to volatile, something you guys are probably going to hear later in this course or this module is probably non-volatile as well. Volatile is the type of memory you get. Non-volatile is the type of memory you get. Volatile is memory that absolutely needs power to be able to function. It needs power in order to remember whatever it is supposed to remember. RAM is an example of that. So when you open a program or a game or something on your computer, it loads that program or that game from your hard drive, which is permanent storage. It loads it from the hard drive into your RAM, which is temporary storage. Your hard drive is permanent storage. It's non-volatile, which means if you lose power to your hard drive, it's not going to forget what it's stored. So it's going to take the information from your hard drive, being non-volatile. It's unfortunately a slow form of storage. It's going to put it into your RAM, which is in fact a volatile type of storage. It's much, much faster. The downside is it absolutely needs power. So it's going to take it from the hard drive, load it into your RAM, which allows your RAM to give it back and forth between the CPU and the RAM, allowing your computer to calculate and work out information a lot quicker. If your CPU had to get information directly from the hard drive back and forth, you would essentially get nothing done. Your computer would be so slow you just smash it to bits most likely. Now the fact that we've got RAM gives you a much faster, smoother experience. So it takes the information out of your hard drive, which is a slow storage but permanent storage, puts it into your RAM, which is a very fast storage but not permanent. Puts it into the RAM, but if you, for example, lose power to your PC, let's say you accidentally yank out the power cord at the back of your computer. If you do that, you probably notice that the next time you start your computer, the program is still there or the game is still there on your computer, but you're going to have to go and reopen it. So the reason why you don't have to go and reinstall it is because it was stored in your hard drive, which is permanent storage, and that's non-volatile. Volatile means if it loses power, it forgets. So that will be your RAM, which is why the game got closed or the program got closed. Just something to guys to keep in mind. And then they've got virtual memory here at the bottom. An area on the hard disk allocated to contain pages of memory. So sometimes it will be referred to as page file memory. So if you go into your hard drive, you actually get to dedicate a small little section of your hard drive as if it is RAM. Now this is not nearly as fast as your RAM. Obviously your RAM is much, much faster than your computer. But there are going to be certain points in time when your RAM might run out. So let's, for argument's sake, say you've got 1 gigs of RAM. You're playing a very heavy game, or you're doing something very resource intensive in your computer, and you're reaching the limit of that 1 gig chip. Now what's going to happen is if you've got virtual memory or page file memory allocated in your hard drive, it's going to go and use some of that hard drive memory as if it's RAM. It's not nearly as fast as the RAM, like we said, but at least it's going to give it that little boost it needs and potentially avoid your computer from crashing. When the average computer runs out of memory, you'll get a blue screen of death. BSOD is what it stands for. Blue screen of death. It's also known as a memory dump. It's also known as a stop error. Now, this is not the only reason why you would experience a blue screen of death, but it could cause one of them. So when your RAM runs out, you get a blue screen of death, something you generally want to try and avoid. Alright, so since we're talking so much about RAM, here's a few RAM types for you guys. You get DRAM and you get SDRAM. Now, SDRAM is mentioned in the course. It may or may not be asked in the exam. I doubt it's going to be in the exam. Normally they don't ask about it in the exam because it's so darn gosh old. But it's something you might still want to know. The chances of you guys actually working of SDRAM is extremely unlikely. So this is something you're only going to experience in the A+ course. You might get in the exam, maybe, maybe not, probably not. But once you go into the industry or once you go back to work, I can pretty much guarantee you it is not something you're going to see at the office. DRAM is the one we use. SDRAM, you can consider it extinct. So what's mentioned about DRAM is it's a type of volatile memory. We know they're both volatile. Any kind of RAM is volatile. So it's a type of volatile memory that stores each bit of data as a charge within a single transistor. SDRAM, on the other hand, is a variant on the DRAM chip designed to run at the speed of the system clock, thus accelerating the periodic refresh recycling times. Sounds fancy, but it's all technology, trust me. At the bottom, you guys can see a little bit extra information regarding DRAM and SDRAM. Feel free to pause here if you guys want to read up on that. Let me move on in the meantime. So with regards to RAM, you get DDR2, you get DDR3, and you get DDR4. Now DDR2, here's a few clock speeds for you guys. Same with DDR3 and 4. This is the only RAMs that the course actually covers, but in reality you actually get normal DDR, which I suppose you can consider DDR1. And there's also DDR5 nowadays. So these are the three main ones. I think the average PCs nowadays uses DDR3. Some of the gamers will probably go and use DDR4 or even better. But the average PC nowadays runs DDR3. That's what you would find on the average PC. Here's some of the specs. You guys don't need to know those off by heart, but it will benefit you to know those. Now, if you're going to go and take a DDR3 chip out of my PC and you try and put it into your PC if your motherboard supports DDR3, physically my chip should fit onto your motherboard, but it does not necessarily mean my chip will work on your motherboard. It might not. So if my chip is slower than your chips, let's say you've got an open slot in your motherboard and your chips is running at an X speed. If mine is compatible on your motherboard, let's say physically it fits into your slot, but my chip is slower than the other chips you have, it will work, but it's going to bottleneck the current chips you've got. So it's going to basically slow them down. So you're actually going to sacrifice speed in that case. If you take a chip out of my motherboard and let's say my chip is much faster than your chips, if you put it into your motherboard, it might fit, but it will not work because my chip might very well be too fast for your motherboard. Each motherboard, you need to go and check whether the chip is physically compatible. Does it physically actually slide into that slot? And then secondly, is the chip fast enough? We don't want a chip that's too slow or too fast, especially too fast. If it's too fast, it's just not going to start. If it's too slow, it might start, but the PC is just going to have reduced performance, obviously. Alright, so let's talk about memory modules. Now, in case anyone is wondering what they mean by memory modules, that is the actual chip that you slide into the memory slot on the motherboard, or the RAM slot on the motherboard. A lot of people refer to these chips as modules or memory modules. I don't actually call them modules. I don't know if you guys call them modules. Neither do I, neither do my friends call them modules. Nobody I know calls these memory modules. The only times I actually hear people calling them memory modules is when I go and do a course. Other than that, nobody calls them memory modules. People normally refer to them as RAM or RAM chips, or even hell, random access memory if need be. That's a mouthful, but even that is something I'll hear more commonly than memory modules. It's just a fancy name for RAM chips. So a memory module is a printed circuit board that holds a group of memory chips but acts as a single unit. If you go hold it up in the air, you'll find those little chips. You'll be able to see them in the air. A DIMM, in other words, dual inline memory module, standard packaging for system memory. There are different pin configurations for different RAM types. Yes, if you hold up different types of RAM, for example, let's say you hold up a DDR2, DDR3, DDR4 in the air, at the bottom of that chip, the part that actually slides into the memory slot on the motherboard, you'll find a lot of little pins. They're normally made out of copper, not necessarily. They could actually potentially be made out of gold and other materials. Those are obviously very expensive. But if you go hold them up in the air, you'll be able to actually see those pins. I wouldn't even bother trying to count them. They're just so darn gosh many. So the more pins you have, the more contact points that RAM chip has to the motherboard. The more contact points it has, the more potential you have for potential speed. It's obviously not the only deciding factor for speed, but the more contact points you have with the ground, the more potential you have for speed. You can think of this as driving on a freeway or a highway, depending on which country you're in. I know different countries call this by different names. So if you have two lanes there, those two lanes can handle an X amount of cars per minute. And if I go and add another lane and another lane, what's going to happen? Potentially, I have the potential to have more traffic now. The more lanes you have, the more cars you can handle. Now, in case you guys haven't made the math yet here, the cars is data. So the more pins I have, the more potential you have to go and handle more data at a given time. So with regards to memory modules, there's a nice little picture for you guys so you can actually see what a module looks like. Now what I want you guys to pay attention to, there's little chips there, those little black thingies, doohickeys that you'll see on the actual chip themselves. But the bottom side, where the little arrow is pointing, those are the pins I'm talking about. Now that one only has a measly 168 pins, but the newer one has way more pins than that. This is a very old chip. The newer ones have got hundreds of pins on them. So that's besides the point, however, that's just to show you what the pins actually are. They're generally made out of copper, but like I said, could also potentially be made out of other elements like gold. Very good conductor. Something you also might want to pay attention to is you'll find that somewhere between those pins there's actually a piece missing. In this case, both of those chips at the bottom has like a little piece of plastic missing there. You'll see it's like a little ditch, if you will. I don't know what you want to go and call it. So in both of them there's two little pieces of plastic missing there. That helps you establish as the IT person which kind of chip is compatible on that motherboard. So a DDR2 can only slide into a DDR2 slot. A DDR3 chip can only slide into a DDR3 slot. So that's one of the ways we identify whether it's a DDR3, DDR2, DDR4 slip chip is by looking at those little holes, between the connectors. So if there's a connector or two missing, that is how you distinguish that. Doesn't necessarily tell you the speed. So to know the speed, you're probably gonna have to look at the actual chip itself. If you're lucky enough, there might actually be a little sticker on the chip that tells you what the speed is. But honestly speaking, 9 out of 10 chips I deal with has no sticker on them, and there's absolutely no indication of what the speed is. You're not going to know until you actually slide it into the motherboard. It's a real inconvenience, but that is unfortunately life. Alright, so some more information about memory modules. Fancy. We get what we call SODIMMs. Now that is something I can guarantee you will be in the exam, is the word SODIMM. Whenever you guys see the word SODIMM, that is RAM that's specific to or unique to laptops. So if I go back to the previous picture, notice those RAM chips there, they're very long in size, very wide. That is a desktop or a server RAM chip. Desktop and server RAM chips, they look the same in physical dimensions. If you look at the laptop RAM chip, look at that one. It's a lot, it's not as wide if you want to go and call it that. Same height, not nearly as wide. It's about a half, maybe 2/3 of the size, physical dimensions of a desktop RAM chip. That is what SODIMMs is. So whenever you guys hear the word SODIMM or you see the word SODIMM in an exam, that is laptop memory. So in the exam, you might get a question that's somewhere in the lines of which one of the following RAM chips will most likely be for a laptop? And one of the potential answers you might see there is SODIMM. So make sure you know that the word SODIMM means laptop memory. Something I want to throw in here as an extra for you guys is, and this is specific to SODIMM chips once again, or SODIMM modules I should say, is when it comes to installing these little modules into your laptop, it's not the same for all laptops. Desktop PCs, that's a different game. You take the cover off, the motherboards generally have the same layout, and you generally go and slide your module, being your memory module, into generally the same area, give or take. Laptops, not the same thing. So for some laptops, it might be as simple as just flipping the laptop upside down, removing one little piece of plastic cover, and there you go. RAM chips are exposed. Where you might find the next laptop, it might even be the same make, might just be a different model of that make. So just a different model of the same make. Suddenly you have to go and strip the whole laptop. You've got to remove the hard drive, you've got to remove the keyboard, the motherboard. So each motherboard is unique. Some of them, the RAM chips, are very easily accessible. Some of them, it's extremely difficult to get a hold of the RAM chips. The same can be said about the hard drive and pretty much all the components in laptops for that matter. They're not the same. So it varies from vendor to vendor and model to model. Just something you guys need to be very aware of. So not something that's going to be an exam. Just if you ever find yourself needing to go and strip a laptop to go and upgrade it, maybe to go and troubleshoot it, be aware that it's not going to be the same for all laptops. Alright, so a little bit more about memory, more specifically dual channel memory. So you get single channel memory, which is for the most part extinct nowadays, and then you get dual channel memory. So single channel memory with 164-bit bus between the CPU and RAM. Now the bus, in case anyone is wondering, is that little roads. You can only see them visually with the eye if you look at the back of the motherboard. So if you flip your motherboard, upside down, or if you go to the opposite side of the motherboard where you go slide the things into your slots, so the back of the motherboard, in other words, you'll find like little pieces of lines there. Those look like little roads, if you want to call them that. Those are buses. So there's 164-bit bus between the CPU and the RAM. Now, the more buses you have, the more traffic you can handle. It's the same as the lanes on the highway or the freeway I was referring to earlier. The more lanes you've got on the freeway, the more cars you can handle. So the more roads you've got on the motherboard, the more data you can handle. So dual channel works in that way. You've got two little lanes that your cars can travel in now, or data in this case. So memory controller with two pathways to the CPU, enabling 128 bits, which is, if you guys haven't done the math yet, is exactly double the 64-bit. So effectively two pathways through the CPU bus, or through the bus to the CPU. 128 bits of data can be transferred per transaction. Installed memory modules should be identical. Yes, that's very true and very important. Not for the exam, just in real life. So if you're going to go and put in more than one RAM module or memory module into your motherboard, they need to be identical. Doesn't matter what the vendor is, doesn't matter the brand, the model, it does not matter what the size is, as long as they are identical. If you're going to go and use memory modules that's different brands and sizes and all that, you're going to get the weirdest errors. I'm telling you now. Sometimes it'll work, but most of the times it will not. You're going to get the weirdest, unexplainable errors. It's stuff that you haven't heard of. It's like spooky stuff. So try and avoid that. This applies to actually anything, not just memory modules. If you're ever going to go and put something into a computer, a server, where you're going to put more than one of the same component, as a rule of thumb, you try and stick to the same brand. Doesn't matter what the brand is usually, as long as you stick to the same brand. So if you're going to go put in multiple hard drives, try and stick to the same brand. If you're going to put in more than one network card, try and stick to the same brand. If you're going to go and build multiple servers and you're going to link them all together in your company, try and stick to the same brand. Alright guys, so all this talk about dual channel, let me show you guys a picture of dual channel. So the average cheapish kind of motherboard you'll buy will probably have just 2 RAM module slots. This one, as you guys can see, has 4. Now, if they have 4 slots, you'll find that 2 of them will be one color, the other 2 will be a different color. In this picture, 2 of them are dark gray, 2 of them are light gray. That is not set in stone. So in real life, they could be any color. The 2 dark gray ones could be blue, and the 2 light gray ones could be yellow, orange. The colors doesn't matter. The point is they're going to be different colors. So what you want to do is, if you have only one memory module, one chip, one RAM chip, you're going to try and put it into the slot that's the closest to your CPU. Doesn't seem like a big deal to us now, but that's actually light years, in distance for your RAM chip. So preferably, it's not set in stone, but preferably you want to start by putting it into the slot the closest to your CPU, which in this case is that dark gray one closest to your CPU chip there. Alright, so once you've got that in, if you find yourself needing to put in a second chip, to go and upgrade the RAM on this PC or the server for that matter, you're going to put it in the second dark gray one. You might think, okay, let's put it into the second slot closest to the CPU, which is the light gray one. No, that's a different channel. You're going to fill up that first channel first, being channel A. So slot 1 there being channel A, you can see that they say DIMM 1 and DIMM 3. So slot 1 and slot 3 is the same channel. Slot 2 and slot 4 is the same channel. So you fill up a channel first before starting with a new one. So if the first slot there is a 2 gig RAM module, the slot you're gonna put the RAM module you can put into the third slot, there's also gonna be a 2 gig RAM module most likely, which gives you 4 gigs. And then eventually one day, should you be lucky enough to get yourself a third chip, you're gonna start at that second slot, which is the second closest to the CPU, and you start the whole procedure all over again. All right, so our next topics here is Parity and ECC. Now you might wonder what the cheese is that. That's actually also RAM related or memory modules related. Everything in today's module has got to do with memory. Either RAM or hard drives, flash drives, DVDs, one way or another, everything in today's module is about memory, one way or another. So parity and ECC, you can probably be assured it's got to do something to do with memory. What exactly? Well, parity checking is actually something very old. We don't actually really do that anymore. The one you guys are probably going to see is either non-parity or ECC. The first one says an error checking method where each byte of data in memory is accompanied by a ninth bit used to check the corrupted data. So we don't really do that anymore. That's old technology. Non-parity, that's what the average computer uses. So if you go and buy yourself a PC in a local computer store, or you go and build yourself one, whether it be gaming or for office use, it uses non-parity. ECC, which stands for error correcting memory, that is something you'll generally find in servers. So servers, those RAM modules, they look the same as desktop memory at first glance. They have ECC built into them. And I can tell you right now, that's very expensive. If you go buy yourself a server RAM module or memory module, they cost way, way more for that. Now, what does it actually do? Now, from time to time, you might encounter a blue screen of death, BSOD, which, like I said earlier, is also known as a stop error or memory dump. Now, this can be for any amount of reasons. Sometimes it's just because your RAM ran into an error. And when that happens, it dumps everything in the RAM. Remember, the RAM is just temporary memory. It dumps it, and when it dumps it, your PC goes into all that fit, where it just gets a blue screen. And it starts the whole cycle all over again. You get basically a clean slate, a clean piece of paper, if you want to go and call it that. Now, can you imagine that happens on a server? We can absolutely not afford for a server to get a blue screen of death. Now, if you ever had the opportunity to go and work on a server, ask yourself, when last have you seen a server get a blue screen of death? Or when last have you heard of someone's server getting a blue screen of death? That just doesn't happen. Why? Because servers have RAM modules in them that's got ECC, error correcting, to avoid them encountering blue screens of death. Yeah, who knew, right? So for you on your personal laptop and desktop, it's going to be non-parity. On a server side, it's probably going to be ECC. Parity checking is just something we are talking about in this module, but it's not something you guys are going to be doing. Alright, so with regards to memory installation and upgrade, this could be any kind of memory, but I think with this they're talking about RAM more specifically, those little memory modules we slide into the motherboard. So if the motherboard supports an upgrade, but the system is not configured to use it, enable dual channel configuration. That is not always going to be possible, boys and girls, so just something we want to make a note of. The last one there says increasing the bus speed requires purchasing a new motherboard. Yes, it is not something you can physically go and upgrade like your RAM on your computer. So if your computer runs out of hard drive space or permanent storage space, whatever you want to go and call it, you just buy extra hard drives or a bigger one. If your RAM runs low or out, just buy more and install it, assuming you've got available slots. But if your bus speed is too slow, the only thing you can do about that is to go and buy yourself another motherboard. That's the actual big circuit board that houses everything, the CPU, the RAM modules, the everything. Everything plugs into it. Now, more often than not, when you go and replace your motherboard, the chances is very, very likely you're going to go and have to go and replace the CPU because the socket size is probably going to be different. And there's also a very good likelihood you might even need to go and change your RAM. That's not set in stone. You might be able to use the RAM from the previous motherboard. So if they're both DDR3, you could just go and use that. But the CPU is almost a guarantee that you're going to have to go and replace that sucker. It's very inconvenient and it's very costly. Alright, so with regards to storage devices, we're not talking about RAM now. Now we're talking about storage. In other words, I want to store something long term. So if I turn that laptop, that desktop, or that server off, and I turn it back on later that day or the next day, I want to be able to retrieve that data intact. So this is mass storage devices. So this could be a lot of things, but I want you guys to visualize a hard drive. So visualize a hard drive in your computer, your desktop, your laptop. That is a mass storage device. You can store a mass amount of information on it. Movies, games, data, you name it. It's non-volatile. We've already said that earlier in this module. So volatile is when it forgets something when you remove the power, like a RAM chip. Non-volatile means if I yank the power out or I take power away from that storage device, it's not going to forget. So a hard drive is like that. If you go and yank out the power cord from your PC, your laptop or your desktop, yes, yeah, whatever programs or games you had up on the PC, you're going to have to relaunch them, but they're not suddenly uninstalled or missing. You just need to go and relaunch the icon. So that is non-volatile storage, guys. So what is non-volatile? It holds data when the system is powered off. Hard drive, remember, not RAM chip. Can be internal or removable. Let's face it, it's probably going to be internal, but you do get hard drives as external hard drives. Sometimes it's very small in size. You just plug a USB cable in and there you go. Sometimes they're very big. You need to go and provide that hard drive, that external hard drive enclosure with additional power. To store data, it uses one of these methods. So we know it's a hard drive, but how does it store data? It could be magnetic, which is what most hard drives do. It's got a little moving spindle. It could be optical, so that's not necessarily a hard drive now. So optical could be a DVD or a CD. Probably going to be a DVD because we don't get CDs anymore. Although you actually don't even get DVDs anymore, never mind DVD-ROMs. If you go buy yourself a computer nowadays, cheap or expensive, you'll find that half of them don't even come with a DVD or optical drive anymore because they know that we don't use them. The only thing you might use them for is to go and install your operating system, but even that gets done via memory stick these days, excuse me, or via a network, not via DVD. It could also be solid state. So the first one being magnetic, that's an actual hard drive. The last one being solid state is most likely a hard drive as well. You do get solid state flash drives, but solid state is probably going to be a hard drive. We normally refer to as an SSD hard drive. Generally more expensive than a magnetic hard drive, but also more reliable, much faster, and that's obviously newer technology. So with regards to your old conventional hard drives, these are referred to as magnetic or mechanical hard drives nowadays. That's what they look like if you open them up. That's not a solid state hard drive, so in case anyone is wondering, that is the old mechanical hard drives, the ones where we tell you, do not drop a hard drive. You might have heard someone say that. If you drop a hard drive, it's bad because you're going to probably lose the data. You're going to corrupt that hard drive. You're going to do a head crash. If you bring a hard drive near a big magnet, let's say you put a hard drive near a speaker of some kind or some other form of powerful magnet, that is bad because you're going to corrupt the data on that hard drive. Not applicable to solid state drives though. So mechanical hard drives, they're basically, what's the word I'm looking for? They're very sensitive is what we want to say. So in the old days, we only had mechanical hard drives and everyone would just refer to them as a hard drive. Now we're sitting at a point in time where you don't just get mechanical hard drives, you also get solid state hard drives. Now solid state hard drives, they're obviously called solid state hard drives, but what do we call the old hard drives now? Because back then we only had the one kind and everybody just called it the hard drive. Now it's not just the hard drive because you get more than one kind. So we need to be more precise. So whenever we say HDD, which actually stands for hardest drive, that could be a mechanical, but it could also be solid state. If I say STD, solid state drive, or SSD, yeah, so it's SSD, that obviously is set in stone. We know it's a solid state drive. But if I say HDD, it could be either or. But generally, if we say HDD, the assumption is there that you're probably talking about the old mechanical hard drives that's got the moving spindle. And if you look there, the top left-hand side of that hard drive, it says actuator. That's an actual arm that moves. In the picture, the arm is on the actual disk itself. It looks like it's on the disk, kind of like a record player, but in reality, that's more than one little arm, and they actually go between those disks. You guys are seeing the disk from the top. In reality, it's more than one disk. There's like millimeters or micromillimeters between those disks, and that arm goes between those layers. Very, very, very microscopic small space between them. So when you drop your hard drive or you bump it very hard, that arm touches the disk. You're not supposed to touch the disk. If you go and touch that disk with your finger, you can kiss your data goodbye. So when you drop the hard drive very rapidly or you bump it very rapidly, that arm touches that disk, and that's why it's bad. So when you turn the hard drive off, that arm goes back to rest position, which is not on the disk. That's going to be more towards the bottom left. We call that position rest. So that's basically what happens when you turn the hard drive off. If you're going to go and yank the power out from a PC, while it's still running, that disk comes to an abrupt, stop, basically, a standstill. And that's bad as well. Solid state drives, it doesn't matter because there's no moving parts in it. It's like a flash drive or a memory stick, whatever you want to go and call it. But these hard drives do not like you removing the power abruptly. Yes, you're not going to lose the data, but it could potentially damage the actual hard drive itself. So you want to try and avoid doing that if at all possible. Now, more information about hard drives here. We've got tracks, data written as a concentric rings on a disk drive, cylinders, so the aggregate of all tracks that reside in the same location on every disk surface. They mention things like disk size there. Obviously, it's much bigger than 8 terabytes nowadays. I've seen hard drives go much, much larger than 8 terabytes. But at the time of the making of when A Plus released this content, it was still 8 terabytes. In reality, we know it's much more than that. And they give you a few other form factors there as well, like the actual sizes. That's probably going to be like an internal hard drive for a desktop and then an internal hard drive for like a laptop. Not the same physical dimensions, but you can actually plug them into one another. Or at least you can plug a laptop hard drive into a desktop, but you can plug a desktop hard drive into a laptop. Now, with regards to hard drives, once again, here is the cables you're going to be connecting to it. So you're going to open your laptop or your desktop. Let's assume this is a desktop PC. You're going to need to go and connect two cables, the one being a power cable, the other one being a data cable. The power cable really is that color. It really is a black connector, and those are the colored wires you're going to see. You don't have to worry about plugging it in correctly because it can only plug in one way. If you look at the top right hand small little picture there, it looks like a little L shape inside of that connector. That's what's going to happen. You cannot plug the power connector in incorrectly. Same can be said about data. So the actual connector itself was probably going to be black, but it's not set in stone. In the picture, you can see the cable is red. It's usually red or pink, but it could actually in reality be any color once again. Cannot plug them in incorrectly. And here's a picture of the motherboard as to where you're going to be plugging in some of those cables. If you look at the bottom right, that is the SATA ports, or also known as serial ATA ports. There's another one there. It says legacy PATA or legacy parallel ATA port. That's for the old hard drives and floppy disk drives, the ones we don't use anymore. It's extremely unlikely you're going to find any motherboard even has that port on it. Unless you happen to have an old PC lying around in your garage somewhere, you're not going to see that port. Now, the SATA ones, this is a very nice motherboard because you can see there, the cables are going to be sliding in from the side, not from the top. Most motherboards, they're sliding from the top, and it kind of gets in the way if you have yourself a graphics card or something. So if I want to slide myself a graphics card into the PCIe slot there, being that one in the middle, that light gray one there in the middle, towards the left, that card is probably going to be pressing down onto the data cables, or it's going to prevent me from plugging them in the first place. So that's not something you want. This motherboard obviously gets rid of that issue. Alright everyone, so I think we've covered mechanical hard drives fairly well. So let's take a bit of a look at solid state drives. So we have already a good idea of what it is. A personal computer storage device that stores data in non-volatile special memory instead of disk types of tape. So the other one was also non-volatile, the old mechanical one, but it wasn't special, it wasn't as safe as it is with a solid state drive. Now, solid state drives, here's a few perks for you guys. I'm going to list a few advantages. First being no moving parts. So there's no spindle, there's no actuating arm, there's nothing that's moving. So you can actually drop that thing on the floor and nothing's going to happen. Obviously, we don't want to do that, but nothing's going to happen. You're not going to lose your data. It's quieter and more power efficient than a normal hard drive, the old mechanical one that is, because it's got no moving parts. So obviously it needs less power. Less prone to failure due to shock, so if you go and drop it on the floor, no concern there. Better read times and less likely to lose data due to power failures. If you remember earlier we said if you go and remove power, from your PC, yes, your hard drive would still have the information, but it's not good for your mechanical hard drives if you've got power failure. Eventually, it might be tomorrow, it might be in 5 years from now, eventually that hard drive will fail. So it's not something you want to go and do, where a solid state, it doesn't matter. You can just yank that puppy out while you're reading or writing from it, and nothing's going to happen. Some disadvantages of this hard drive is very expensive. Obviously, the prices come down quite a lot now, versus in the beginning. So in the beginning, I think a solid state drive was easily about 10 times more expensive than a normal hard drive. So if you paid $1 for a gig On a normal hard drive, you'd pay $10 per gig on a solid state hard drive. Now it's come down, to about half of that, if not more. It's gotten a lot cheaper. It's all about supply and demand. Another type of hard drive that you guys might hear of is hybrid drives. Now, I don't see these often. When I was working in the industry, I used to sell some of these to some of my clients, and the only reason why I would sell them is because the clients specifically requested them. But unless the client specifically requested, I would not sell them a hybrid hard drive. I've got my reasons for it. So as someone that used to sell these, I can tell you that I had a lot of comebacks. I don't know why. Maybe they've addressed these issues now. It's got nothing to do with the make, the vendor, the model. It's got nothing to do with the size. It's just I had bought more than 90% of those hard drives would come back. So they just failed like crazy back then. So ever since then, I had a bad experience with them, and now I just tend to stay away from them. Maybe they fixed them because it's obviously been a few years, but back then I had a very bad experience with them, so I just try and avoid it. So what happens is the mechanical hard drive you guys already know has moving parts. The solid state hard drive has no moving parts. Way faster, way more reliable, but very expensive. Hybrid is when you go and take your old conventional mechanical hard drive and you basically marry it with a solid state hard drive. So if you have yourself a terabyte hybrid hard drive, you might find that only 50 gigs or 100 gigs of that is solid state. You can think of that as the cache. We call that a cache. So any data that you access very frequently, that you need at very fast speeds, like your operating system files, that is going to be on the cached portion, being the solid state section. And then data, which is, stuff that's more like storage, stuff that you almost never access, might be a movie, might be some document, anything like that will be on the normal mechanical side of the hard drive. So it's very intelligent, it knows, it can see what you're using very frequently and what not. And whatever data is being accessed very frequently will be added to the cache section, being the solid state section, which is much faster. All right. All right, boys and girls. So here is some guidelines for installing mass storage devices. This is obviously your hard drives, in case you guys don't remember. The first one is, does the computer have existing internal storage devices? So if this is a laptop or a desktop, if it has an existing hard drive, it might be in the way, especially for a laptop. Laptops generally only have room for one hard drive, and if you want to go and put another one in, you're going to have to remove the old one first, otherwise it's not going to work. Desktops, not so big of a problem because they generally have room for at least 2 or 3 hard drives, even the cheaper cases. If you buy yourself a very fancy, expensive case like a gaming case, then you might have room for 6, 10 hard drives. You could have a room for a lot. But the cheaper cases normally have room for at least between 2 and 3 hard drives. So are there any existing hard drives in that computer? Because they might be in the way, and it might be something you need to consider if maybe they've got an operating system installed in them or not. Does the device need additional drivers installed? So if this is your very first hard drive you're installing on that computer, in other words, the main hard drive, you're probably going to have to go and install drivers as well, never mind the operating system. If you're going to take a hard drive that already has an operating system installed on it, you might need to go and reinstall the drivers. So if I have an existing computer that's got Windows on it, it's got everything on that hard drive, and I take that hard drive out of that computer and I basically transplant it like an organ into a different computer. Yes, you can boot that hard drive. Yes, you can start that computer. But with that computer being a different computer, it's got probably a different motherboard, different network card. All the hardware is different, which means your drivers are most likely incorrect now as well. So it's still going to boot, but your graphics is going to probably look distorted. Everything's going to look whack. So you're probably going to have to go and install additional drivers in a situation like that then. Does the computer have an available power supply cable to supply power to the device? Now, if this is your very first hard drive or even your second hard drive, this is probably not going to be an issue. There's probably guaranteed going to be a cable there, even if it's a cheap power supply. But if you find yourself in a situation where you've already got a lot of other hardware devices in that computer, potentially other hard drives, then there might not be an actual cable available. You're going to have to go and get yourself a splitter that splits one of the existing cables, but you need to bear in mind that you don't want to put too much power strain or drain on that rail. So each rail has a certain amount of amps it can provide. Normally it's about 1 amp. So if one rail has 3 connectors, you can go and pull 1 amp out of those 3 connectors between the 3 of them. But if you plug one device into those three connectors and that one device already pulls 1 amp, then the other two connectors, they might be there, but you can't go and plug something into them because you already drawn the maximum amount of amps for that rail. Something we'll go into more depth in a later module. So not something you guys need to be worried about right now. The only thing you need to be worried about right now is, do you have a power connector for that hard drive? You might not. Does the computer have an available drive bay for a storage device? Something we've mentioned already earlier. So if it's a laptop, probably going to be a concern. If it's a desktop, unlikely. Do you have the necessary data cables to connect the storage devices to the controller? Now the cables themselves is not something you should worry about. Those you can get anywhere for very, very cheap. It's more the ports on the motherboard where you plug those cables into, which is a concern. Do you have any open ports? The average motherboard has about 4 of those ports. It could be less, could be more, but there's about 4. So if you go plug an optical DVD drive in, it's going to occupy one of those ports. If you potentially have any other existing hard drives on that PC, that's also going to occupy some of those ports. So do you have any spare ports on the motherboard is your concern here. Does the placement of the device interrupt the airflow of the case? Usually this is not really a concern, but I have noticed with most computers, including gaming cases, with most of them the hard drives is in the front of the case. And generally then there's actually a dedicated fan, sometimes more than one, which specifically blows on your hard drives. And the rest of the case has its own little dedicated fans to go and make sure airflow continues like normal. But there's a dedicated fan in the front of the case which normally blows on the hard drives to keep them cool. Something some of you guys might not know about. Okay, and then we have removable storage. Yep, I'm not kidding. And I think this one doesn't even need explaining. So removable storage is pretty much anything you can go and plug into your PC, your desktop, your laptop, even server in some cases, and you can go and remove. It could be something like a memory stick, which is also known as a flash drive. It could be something like an external hard drive you slid into a USB port. It could be something that you put into your optical drive, like a CD or DVD. Anything that you can go and connect to a PC, which allows you to store data permanently for that matter, and then remove it. So DVD, CD, flash drives, which are also known as memory sticks, external hard drives, all of these are seen as removable storage. So the reasons why you go and use them is completely unique to each person. The only thing that I might want to add is I see one of the points there is used for backupping. Yeah, I suppose you can go and use them for backupping, maybe in your personal capacity, but in the industry, we don't really go and use that for backupping. It's not the best way to go about it. In the industry, we'll go and use tape drives, we use NAS drives, file servers, and even offsite backups, but that's not the best way to go and do it in the industry. So personal backups, sure, go for it. Then we have optical media, which is pretty much the same thing, well, partially the same thing as what we just said previously. So this is also a form of removable media. So I suppose you can think of this as a subcategory of removable media. You had your old CD, which stood for compact disc. You have your DVD there. And yeah, CDs were generally about 700 megabytes in size. DVDs originally were about 4.5 gigs in size, and then they went up to about 8 gigs, some of them, and then some of them even went as much as 17 gigs or more. What's not mentioned here is some of these DVDs might sometimes be double-sided. So you can actually put it into your optical drive and you can open it and you can just literally flip it upside down. It will actually store information on the other side as well. So that was possible, but it was very inconvenient at the time. So since we're talking about optical media, there is what a drive looks like. That is probably a CD-ROM. It doesn't really look like a DVD-ROM, but you never know. It might be. And flash memory devices. So memory sticks or flash drives is something we still use till this day for pretty much just about anything. SD cards, well, it depends. Maybe in some phones we'll use them in various sizes. When I say sizes, I don't mean storage size, I mean the actual physical dimensions size. So you'll get them in phones, you'll get them in cameras, you'll get them in all kinds of devices these days that's got some sort of camera connected to it. So it's a solid state type of storage. Any type of persistent digital storage technology that does not use mechanical parts is solid state. So flash memory, which means it's very quick, and it's also memory cards. Alright, and then we have external storage drives. So we have spoken about this indirectly a few times already. The last time was when we talked about removable storage. So you get storage drives like external drives in different shapes and sizes. You get the kind that will basically fit in the palm of your hand. That actually contains or houses a laptop hard drive. All you need to go and do is you just plug a little USB cable into it, plug that aside into a PC of your choice, and there you go. No external power source required. When you get the kind that's very large, you almost need like 2 hands to carry it because it contains a desktop hard drive. Desktop hard drive ones normally need external power as well. You're going to have to plug it into a power source besides the little data cables you're going to have to plug into a PC. You're going to have to plug it into an external power source as well, which becomes very inconvenient if you're nowhere near an external power source. So with regards to drive enclosure, an external case that holds one or more disks and typically connects to the computer through USB or Thunderbolt ports. It's usually just going to be one hard drive. When they say USB, it's usually USB-C or USB-C. It looks exactly the same as the Thunderbolt cable, except the Thunderbolt one is much, much faster because it was originally designed for Apple. But they are compatible with one another in case anyone is wondering. Alright folks, we have a new topic finally on our hands, and this is called RAID. You get many kinds of RAID, but the only ones we're going to be discussing in the A+ course is RAID 0, RAID 1, and RAID 5. There are, however, other ones out there. I just want to make you guys aware that there are other ones out there. You do not need to know them, however, for the exam. Very unlikely going to be working with them as well in the industry. It's quite rare. So for this course and for the exam, you just need to know about RAID 0, RAID 1, and RAID 5. What do we use each of them for? What is the benefits of each of them? And what are the cons of each of them? What are their speeds and all of that? Just the very, very basics. So we'll go into it in a moment. So RAID, being redundant array of independent disks, is a set of vendor-independent specifications for fault-tolerant configurations on multiple disks. So, but it depends on which kind of RAID configuration you have. Some of them gives you speed, some of them gives you redundancy or fault tolerance. So redundancy or fault tolerance means if I have more than one hard drive and one of them fails, breaks down, gets corrupt, I lose no data. That's redundancy. Now, some of them will give you redundancy, some of these RAIDs. Some of them only give you speed. But if I lose one of my hard drives, I lose my data. It depends on which RAID we're using. So let's look at the first one here being RAID 0. Alright, so disk striping, a disk array access pattern where data is written in stripes to 2 or more disks sequentially, improving performance. Alright, so that's what 0 is all about. 0 is specifically and strictly just for performance, guys. It's not going to give you redundancy. So let me be clear, no redundancy, no high availability, strictly just for performance. So with regards to the exam and also a little bit in industry, you need to know what are the minimum amount of hard drives you need for RAID 0, 1, and 5. We're still getting to it, but for 0, you need a minimum of 2 hard drives. For RAID 1, you need a minimum of 2 hard drives. And for RAID 5, you need a minimum of 3 hard drives. So for the exam, you need to know what they do, striping, mirroring, and with parity bit, or the minimum of hard drives, and obviously pros and cons and all that. So they mentioned a few things here regarding RAID 0, which you guys can go read up about, but in a nutshell, as long as you know RAID 0 involves having at least 2 hard drives, it's going to write data to both of them, it's going to split it zigzag between the 2 hard drives, giving you performance. Because what is the slowest component in your computer? It's usually your hard drive. You can have a very fast CPU, fast motherboard, fast graphics card. At the end of the day, if you have a normal hard drive in there, that hard drive is going to bottleneck everything in your PC. So if you can go and get yourself another hard drive, and basically in a nutshell, split the data between the 2 hard drives, half, and read from them both at the same time, then yeah, that's actually going to give you a huge boost in performance. Downside is if you lose any of those 2 hard drives or more, you lose your data. So it's not for redundancy, it's for performance. So let me show you guys a picture of what this actually looks like. There is your PC, and you'll see there's 2 hard drives. So those 2 columns there, that's the 2 hard drives, and your data is split across the 2 of them. So you see data 1, one hard drive. Data 2 is another hard drive. Data 3 is the first one, data 4 is the second one. So it's going to go zigzag between the 2. So if I lose any of those 2 hard drives there, I'm screwed, is what I'm going to say. RAID 1, this is in fact for redundancy. So 0 was for speed, RAID 1 is for redundancy. What is the minimum amount of hard drives I need? 2. So just like RAID 0, I need 2 for RAID 0, I need a minimum of 2 for RAID 1, and a minimum of 3 for RAID 5. So RAID 1 gives you mirroring, which basically is cloning. So you're going to need a minimum of 2 hard drives, and they're exact replicas of one another. We use this in a lot of things. You can go and use this in NAS drives, We use this all over the place. So RAID 1 gives you redundancy. If I lose a hard drive, one of them gets corrupt, that's no problem. I simply just remove the failed hard drive, put another one in there of equal size, and it's going to start replicating. How long it takes to replicate obviously depends on how full a hard drive is and how much data it actually has. So based on my experience, it takes on average about a day and a half per terabyte. So if you've got 2 terabytes, that's going to be about 3 days. If it's 3 terabytes, it's going to be about 4.5 days, just to give you an idea. That's not set in stone, that number. That's just more or less the average period it took me to go and replicate that. So yeah. Now, yes, it's used mainly for cloning and all that. But if you do have 2 identical drives, writing to them is not really going to give you a performance boost, but reading from them does give you a slight boost. If you look at the third bullet point there, it says read operations can use either disk because they're identical, which gives you a small little performance boost. Now, unfortunately, if one of those 2 drives should fail, you're going to obviously lose that little performance boost there. You're not going to lose the data, but you're going to lose a slight performance boost there. So let me show you guys what this picture actually looks like. So same pictures earlier, except this one is slightly different. It's not zigzag. There's 2 hard drives, and as you can see, they're identical to one another. I can literally go and remove either or either or could go and fail, and that's no problem to me. I simply remove the failed hard drive, put a new blank one in, and about a day or 2 later, I'm back up and running. No problemo. Now let's look at the last one here being RAID 5. Uses striping, mirroring, and parity bit. Now RAID 5 is actually the most commonly used one that I would normally see in the industry. RAID 0, you could use that on the desktop PC of your own, your personal PC. RAID 1 as well, but I don't really see people using RAID 0 and RAID 1 in their personal capacity on their personal desktop PCs. Maybe about 10 years ago, people would go and do that to give themselves a slight performance boost because back then, we didn't have solid state drives like you guys do now. Nowadays, it's much quicker, easier, and cheaper just to go and buy yourself a solid state hard drive, plug that sucker into your motherboard, and there you go. It's going to give you performance, and it's going to be very cheap to go and put that in. But if you want to go get yourself RAID, you have to get yourself a special motherboard, RAID controllers. You have to have a fair understanding of what RAID actually is, how to go and configure it. It was a huge schlep and inconvenience. Now, RAID 5 is not something you can do in your personal capacity. That is for servers usually. So I would see that all the time in companies, sometimes even higher than RAID 5. But RAID 5 is the cheaper one of the lot. Gives you striping, gives you mirroring. So it gives you performance and reliability. And using these little parity bits, you can actually establish what is missing if one of the drives fails. So if I have myself 3 hard drives, which is the minimum, and one of those 3 hard drives fails for whatever reason or goes missing, it can use the other 2 hard drives to figure out what is missing and basically reconstruct itself. It uses the parity bits to figure out what's missing. So here's a picture of that. There's 3 hard drives, and if you look at the first one, it says data 1, the second one says data 2, and on the third one, it's got a parity bit there in that exact slot. Now, if you go with the first hard drive again, it says data 3, and now with the middle one, it says parity bit there. And then on the fifth one, the last one there, it says data 4 again. So it keeps that parity bit just keeps moving around. So all over the place, it's just going to keep moving around, zigzag the parity bit. So as soon as one of those hard drives fails, using the parity bits, it can figure out what is missing and reconstruct that hard drive as soon as you slot a new one in. Alright everyone, I hope this has been informative. If you have any questions about any of the topics I've discussed in this specific module, you're more than welcome to drop your questions down below in the comments, and I will gladly get back to you as soon as I can. Alternatively, feel free to look in the description of the video and you will find a link there to a Discord channel that I'm in, or Discord server I should say. It is not my server, but it is an IT community that's got about 2,000 or more IT people in it. Some of them are people that are experts in the field. Some of them are just people that's studying like you. Either way, you will be able to find some support there as well for A+ or other courses. So if you're looking for me on that server, I'm normally listed as Burning Ice Tech, the same as the name of the channel. Feel free to just send me a DM there and I'll gladly get back to you with whatever question you have. So you can either send me a direct DM on Discord or you can just go and chat in the group. It might be better just to go and drop a discussion or a comment or a question there in the group, because 10 to 1, other people have the exact same question. Normally if someone has a question, someone else has that exact same question. Okay guys, so it's that time of the video. Please give the video a like if you found it informative. It really does help support my channel. And if you would like to know when the next module of this course comes out, please smash the subscribe button, maybe with the notification bell. At least then you'll know when module 5 comes out and so on and so forth. Alright guys, I will see you on module 5 of A+. Have a nice day.
If you love me, let me know. If you don't, then let me.